Hey everyone, thanks for tuning back in. My name is John. I'm a business development manager here at Celemics. So the agenda for today's presentation is for me to briefly talk about a specific challenge that many of our customers have faced when dealing with low quality or highly degraded FFPE, and then how they utilize the Celemics Kits to overcome that challenge. So to start off, I wanted to share a study our scientists have done in the past in which we wanted to test what the sequencing data would look like when starting from highly degraded FFPE. In this particular study, we ran a number of individual experiments with the conditions of starting with different amounts of DNA input derived from clinical FFPE DNA, and then assessing the performance, most notably the on-target read ratios, mean depth, coverage, and uniformity. So we ran these studies utilizing our Celemics Enzymatic preparation library prep kits, as well as our cancer screen panels. And finally, the sequencing was done on the NextSeq 500. For starters, we wanted to see what the performance would entail using reference FFPE samples, so we procured highly degraded FFPE reference standards and then tested it in two different conditions. One with the DNA input of 10 nanograms and then two with the DNA input of 50 nanograms. So you could see from the chart here that the performance summary for the 10 nanogram samples that we had an on-target read ratio of 77.45%, and then for 50 nanograms we had 82.88 and then 80.36 respectively. And then for the 0.2 coverage, mean, and uniformity, you could see that the standards generated a 94.38, 93.78, and then 92.01 respectively. So moving on to our experiment using 7 samples of clinically FFPE-derived DNA, we enacted the same 50 nanogram parameter and applied these 7 samples to our library preparation and solid tumor cancer panels. So you could see when utilizing the Celemics library prep and capture probes, the performance we had surpassed the performance done using the reference material and the parameters of on-target read ratio, uniformity, and coverage score. For the conditions of 10 nanograms of clinical FFPE samples, a little bit more of the same story. We tested 7 samples in total, and we found that the panel outperforms the on-target read ratio, uniformity, and coverage score. We wanted to assess performance and evaluate low allele frequency detection, and proceeded using the 50 nanograms of standard FFPE DNA to apply through 2 kinds of Celemics cancer panels, which had a target size of 400 kb and then 2.2 megabases. So you could see from the table below that the mutations were detected at the same variant allele frequency as present in the standard material, and also variants with an expected 1% allele frequency, such as the EGFR T790M variant, was also successfully detected as well. Now I wanted to highlight some of the key points as to how we're able to achieve these results. So when dealing with highly degraded FFPE extracted DNA, it's essential to have a high library yield when trying to detect mutations. So some of the advantages that we hold with our technology is that we first produced our enzymes with optimal conditions, such as our buffers and enzyme concentration, and this allowed us to achieve a library yield, a high library yield. Secondly, we have chemically modified our index adapter primers, and this optimization allowed for adapter primer annealing to amplify with the adapter ligate library. Lastly, our amplification polymerase kit allows for optimal conditions for high yield amplification, which also in turn allows for less bias and amplification for the library. As far as our products go, many of our customers use our Cancer Screen Comprehensive panel in conjunction with highly degraded FFPE samples, so I wanted to introduce this panel briefly. This panel is both a DNA and RNA panel consisting of 697 DNA and 68 RNA genes, and it's an excellent tool to detect all variant types and immune oncology markers. Our Cancer Screen Comprehensive is compatible on the Illumina platform, and more labs are finding value in this very comprehensive panel to help them identify significant mutations and variants for solid tumors. In conclusion, if you have any questions regarding this presentation or about our Cancer Screen Comprehensive, please don't hesitate to reach out to our US branch. In the next presentation, I'll be going through our Cancer Screen Comprehensive panel in more detail and depth, and also explain its capabilities. Thank you.